Good day, my dear students. I welcome you all to today's class, and I hope you are keeping safe. You're staying safe everywhere you are. God will continue to be with us. Today, we want to look at a topic in sort, and the topic for consideration today is rationalization and simplification of sorts. Rationalization and simplification of sorts. And the lesson objective for today is that at the end of the lesson, students will be able to rationalize and simplify sort problems. So you, by the end of today's lesson, you will be able to rationalize and simplify sort problems. Don't forget, rationalization and simplification, they go hand in hand. So as you are trying to rationalize, you are simplifying, and if you are simplifying, it does not really mean that you are rationalizing. So but rationalization and simplification of sorts, they go hand in hand. Now today we want to look at what rationalization of sorts means. Rationalization is a method of simplifying a fraction having a sort either as its denominator or as both the denominator and numerator, such that it can be rewritten without a sort in its denominator. The sort in the denominator can either be a singular sort, it can be a mixed sort, or it can be a compound sort. A sort can be turned into a rational number by multiplying it with its conjugate. What does the word conjugate means? Conjugate is just the opposite of a sort. And how do we get that opposite? We get the opposite of that sort, the particular sort given, by changing the symbol or the sign in that sort. Take for instance, if you have addition in that in a particular sort that is given, to get the conjugate of that sort, you just change the addition sign to subtraction, that's to negative. If it is plus, you change it to negative. Take for instance, if you have a plus root b, what will be the conjugate sort of a plus root b? It is a minus root b. If you have c minus root d, what will be the conjugate sort of c minus root d? It becomes c plus root d. So let's continue. We said a sort can be turned into a rational number by multiplying it with its conjugate. For this reason, this process is often referred to as rationalizing the denominator. What we mean is that to simplify a fractional sort having a sort as its denominator, we multiply its numerator and denominator by the conjugate of the denominator. So what we mean is that if we are going to rationalize, take the conjugate of the denominator of the sort that was given or that is given. The conjugate, use the conjugate of the denominator of the sort given to multiply the numerator and the denominator of that same sort that is given to you. And that is rationalization. That's rationalizing. So rationalizing the denominator often takes the two following forms. The first form, if you have a over root b, a over root b, if you are to rationalize a over root b, if you look at it, the denominator of the sort given does not have any sign therein. So all you just do is to multiply the numerator and the denominator by the denominator of that surd. So A over root B will be equal to A over root B times root B over root B. And then when you multiply the numerators and the denominators together, you have for the numerator you have A times root B, giving you A root B. And the denominator you have root B times root B, giving you B. Not only that, the rationalization of the denominator can also take another form in 1 over A plus root B. And you need to take note of this form very well. A over 1 over A plus root B. What is the conjugate surd of A plus root B? A minus root B. Very good. So you have A minus root B multiplying 1, which is the numerator, and A minus root B multiplying A plus root B, which is the denominator. So when you carry out the simplification process, you have for the numerator 1 multiplying A minus root B, and that is A minus root B, all over A plus root B multiplying A minus root B. In the normal expansion procedure of our quadratic expressions, you have A plus root B multiplying A minus root B to give us A square minus root B square. And you know that root B square will give you B. So if you rationalize 1 over A plus root B, your answer is going to be A minus root B over A square minus B. Let's have an example. 1 over root 2 plus 1. 1 over root 2 plus 1. We are going to rationalize that. And you know that in this question, what is the denominator of the surd that is given? The denominator of the surd given is root 2 plus 1. What is the conjugate of root 2 plus 1? Good, root 2 minus 1. And then what it means is that 1 over root 2 plus 1 will be equal to 1 over root 2 plus 1 times root 2 minus 1 over root 2 minus 1. And when you multiply the numerators, you have root 2 minus 1. The denominators will give you root 2 square minus 1 square. And you know that root 2 square will give you 2. Minus 1 square will give you 1. So you have your answer to be root 2 minus 1 all over 2 minus 1. And your answer will be root 2 minus 1 all over 1, because 2 minus 1 will give you 1. So anything over 1 is still that thing. So A over 1 is A. So it means that root 2 minus 1 over 1 is equal to root 2 minus 1. And that becomes your answer. But I want us to quickly simplify, or you rationalize this surd that is given here. 1 over 5 root 7 plus 4 root 11. I want us to do it quickly, and you post your answer to me right away on this platform. And thereafter, you will take up this assignment, which I want you to submit to the Google Classroom. Very soon that is going to be assigned for you there in the classroom, in the Google Classroom. And I want to have a maximum participation. Okay, so I want you all to try your hands on them and do them, and as we continue in the lesson. Thank you.